In this video, we are going to understand the concept of congestion avoidance and control. Before that, we need to understand what is congestion collapse. So whenever IP gateways are connected to network of widely different bandwidth, packets coming to it will be in queue, and when RTT exceeds to maximum, IP gateway will receive extra some copies of same packet. This will worsen the network with congestion. This simply means the source is sending packets or data and the destination or any hops in between will receive the packets, and if the RTT time exceeds to its maximum, that means the time within which it was supposed to respond or process it exceeds. In that case, another copy of the same data will be sent, assuming that the previous one was lost. This will result in sending same copies of same data again and again, and this will simply congest the network, and this situation is known as congestion collapse. To address this problem, various mechanism has been implemented. There are certain methods to handle congestion collapse. One is flow control, second is congestion control, and third is congestion avoidance. Let us understand what is flow control. It is a mechanism to prevent sender and receiver from overwhelming the receiver with the data. So basically, sender and receivers are restricting the data they are sending or receiving from flooding each other with the data. So sender and receiver advertises their receiving window, in short it is RWND, and each ACK packet will carry latest RWND value so that receiver will know how much to send. So as we discussed the three-way TCP handshake, that is TCP connection, SYN, SYN-ACK and ACK package are being transferred with the help of flow control. What we are doing is, with ACK packet we are sending RWND size. It is the size that it can receive at that particular moment, so that whenever the sender is sending the data, it will not overflow the data, and it will only send the data that is acceptable by the receiver at that particular moment. So here we are controlling the flow from sender and receiver both sides, and both of them are advertising or publishing their RWND size. That means the amount of data they can handle at that moment. In this way, they are helping each other not to flood or congest the network. This is flow control. Another concept is window scaling. So initially RWND size was of 16-bit. This imposed a hard upper limit, that is the max value could be 2 to the power 16 or 65535 bytes. You must have seen this number in Linux in hard limit and soft limit. So this is what the number is. In RFC 1323, TCP window scaling option was introduced. This allowed to raise RWND size from 65535 bytes to 1 GB. On Linux, window scaling option can be checked with following command: sysctl net.ipv4.tcp_window_scaling.